Okay, students, so we're back for part 5 of Lab 8. And in this part of the lab, you're going to work through different analyses and visualizations of Landsat data. And remember, we're comparing 2022 and 2023 June Landsat scenes. We're going to visualize them in red, green, blue, like a natural color image, as best we can using composite bands. And then we will visualize the land surface temperatures across the images as well. Instead of using reflectance data, we'll use surface temperature data, or basically thermal infrared bands. And then you will use near infrared and red to make a normalized difference vegetation index and visualize where in the landscape, in this desert landscape, there are active riparian zones and other areas of vegetation. And we'll compare, hopefully the goal is for you to output a false color image of temperature, output a true color image, and make a figure of showing changes in healthy vegetation by year. So you could make a side-by-side image, or you could difference the two, and you can compare the area of land with and without vegetation in 2022 to 2023 in these very different rain years, right? Remember that 2022 was one of these exceptionally dry years in Utah, and 2023, on the other hand, was exceptionally wet. And so we want to see if we can see changes through this landscape. Okay, so to start off with, we're going to do composite bands. And that allows you to basically take individual rasters and put them together with different channels of information in one. And so in this case, we're going to take red, green, and blue channels of the Landsat and put them together so we can visualize those three colors together and make a natural color image. So you can do it by drop down if you've got those things open. I don't have them open, so I'm going to click on folder. And I will do this for one of them, but you would proceed to do it for the others as well. I've already done it, so I can show you what both look like. So red, green, and blue are under reflectance within Landsat. And so band 1 is like ultraviolet, band 2 is blue, band 3 is green, band 4 is red, and then we go to near infrared bands and shortwave infrared bands after that, and then we have thermal bands under surface temperature. What we're going to be after is band 2, 3, and 4 for this, but I suggest that you input them by first clicking on band 4, which is red, press Control, then band 3, and then Control holding that down, band 2. So that adds first red, which is band 4, green, and then blue. The order that you add these will be the order that it shows up in the default color image. And by convention, people say red, green, blue in color theory, but in terms of wavelength, it's actually blue, green, red, which is why it's band 2, 3, and 4 in here. But if we go 4, 3, 2, it'll match up, and you don't have to do a lot of work to get it to look right. Okay, so then you would output your raster, and you could call it whatever you want. You could call it RGB 2022 or RGB 22. Okay, run. Not too hard to do this one. And so this should just pull this up here in a minute. And I've actually already done it, so we can cheat, right? I can open these and turn them on for you. But here it comes, okay. So I've got a bunch of products that I already pre-processed, but the new one showed up here. So you can see the Landsat scene that we collected here, and we can see this nice San Rafael swell. And we can see the colors. The vegetation areas do look green. We can see snow on the mountains still up on the Wasatch Plateau. Yeah, so it looks like a natural color image. Red is band 1 of our composite image. And we selected band 1 to be band 4. So really that's band 4 of our Landsat. So realize that you should take notes on this. What did I input for this RGB? Because it loses that input information as you add it. We can make it a false color image, like you can display blue as red and so on and so forth by just going to symbology and switching these up. So if we switched it up, we're going to see the landscape will look kind of funky. And that's because we've changed the blue and red channels. And if we had ordered them by 2, 3, 4, this is what it would have looked like, and we would have had to swap these back. But if you do it the way I showed you the first time, you'll be done. So yeah, that's composite bands. I have already done it for the 2 different data sets, so I'll turn that one off. So here's 2023. Loading a few too many things, hold on. And 2022 is underneath. Okay, so let's compare those. I'm going to turn off a few other things so it's not drawing too much. So on top is 2023. Look at this. You can see a lot of kind of dark across the landscape, and compare that with 2022. The surface brightness is a lot different between these 2 scenes. And so that probably has something to do with soil moisture and how dry it's been. Could have a little to do with kind of the ambient light of the day and things like that too. But I think that's cueing us in that we're going to see very different things with both surface temperature and normalized difference vegetation. Okay, so that's how you get your true color image. Okay, to visualize land surface temperatures, we need to load different bands together. So let's minimize these surface reflectances for a minute, and we will open our surface temperature ones. So I've already pulled up these results, but I won't load them because I want you to do this and follow my steps. So let's go back to catalog. We go to Landsat and we'll open the temperatures. And I tell you in here to get surface temperature band 10. So hopefully you can see which one that is. Okay, so band 10 is here. Okay, so this will be for 2022. Load that to 2022. And here's band 10 for 2023. Put that in there as well. Okay, so I'll try to make this show up. I'm going to turn off these. So here's our surface temperature maps of it's turned on. Okay, so yeah, there's the 2022 and 2023. So 2022, you know, basically the temperature values that you're going to see are going to, so these are products that I've already made, so I'm going to minimize those for a second. And actually, I've got this one in the wrong place, so this should be within that. It should this. Okay, so each of these is band 10 for the different years, 2022 and 2023. And these are coming as digital numbers. I think it's like 16-bit digital numbers. But that's not true temperature, and so we need a conversion factor to get that. And to get it into Kelvin, it's this surface temperature times this number plus 149. Okay, so we can do this math in a couple of different ways. So if we go back to geoprocessing, one place to do this is under map algebra, excuse me, which is raster calculator. Because these are rasters and we can calculate on them. You can add, subtract, multiply, divide, etc. There's also a math tool that kind of is more stepwise, and there might be even some clearer functionality to it, but a lot of times it's pretty simple to use raster calculator. And so we might need to make this bigger so we can see that we've got the right things while we're working here, because we're after these band 10s. Okay, so what I suggest you do is basically follow this formula that I have here, but I suggest that you input it directly here as opposed to copy and paste, because sometimes the syntax doesn't get quite right in the copy and paste. And so usually what we would do is this. So we would pull in the band because it's surface temperature. Let's do the 2022 first. So I hit enter, it double clicked and it appeared. And then I'm going to multiply that. Okay, so I'll double click this operator, multiply. And then I'm going to put 0. I'm going to type it in and see if this works. But sometimes you have to worry about parentheses. And of course, PEMDAS, right? 00341,802. Okay, and then it's plus 149. That gets it to Kelvin. And then minus, a double click here, 273.15 gets it to Celsius. And if you want it to be Fahrenheit, then we need to do a multiplication. And here I'm going to use the parentheses, 9 divided by 5, parentheses, plus 32. So this may or may not work. I'm going to hope it works. The output raster, if it's going in the geodatabase, good question. I'm going to call it, we're going to call this L for Landsat, surface temperature 2022 F for Fahrenheit. And I'm not going to give it an extension because I'm worried that if I call it .tiff, it'll fail because I've seen this happen a bunch of times in the geodatabase. So let's just run that. It actually does not look like it worked because the values are not what they should be, right? It's all negatives. So it operated, but I don't have my parentheses right because it should range from all positive values. So let's remove that and see what I could have done better. Let's add some parentheses. So first thing I'm going to do is add parentheses around my data set. And then I'm going to add parentheses around this stuff over here. And I think that might do it. So 2022 FB for run B. Okay. Let's see if this works. It did give me decimals, which is nice because I was worried that it wouldn't do so. And yeah, this is not right either. So still don't have something quite right. So let's look through here. Because these are all negative values again, too. They've gotten much bigger. I'm going to remove that. So I'm going to put a parenthesis around this first multiplication. And then I'm going to put a parenthesis around those two things. And I'm going to put a parenthesis around all of this. Okay. You can also do this stepwise. You could do first just do the multiplication and plus 149. Then you could subtract that. In fact, in that case, maybe what I want to do, I'll add another parenthesis here, here. Then it's kind of like I've done that, and then I minus 273.15. So I've added a few more parentheses. Let's run it now. Sometimes going stepwise, first turning into Kelvin, then Celsius, so on and so forth, is going to be a better option. And I think that might be what we have to do. I could do one more attempt. Actually, I should set the parentheses up like I've got right here, right? So let's try this copy. And we'll paste it in here. So we'll delete that. This is a violation of what I told you at the beginning. And then I'll highlight that TIFF. And I'll instead find the 2022. I want to delete that TIFF, sorry. And then I'm at that location. Sure, I'm at that location. Double click. Okay, so there it went inside of that parenthesis. And then if I have all my other parentheses right, it should work. And I think I might have set it up that way with X copy and paste. So let's try and run that. I forgot to change it to run C, but hopefully it'll overwrite it. Oh yeah, that worked. Okay, so yeah. Okay, so you can simply copy and paste the formulas that I have here if you want it in Fahrenheit, Celsius, or Kelvin. You just change the variable of which surface temperature band you're using and make sure it is there in quotes. And then you should be able to run it. Okay, so there's my surface temperature values. So I put that down here in 2022. I've actually already run it, and you can see it here, the same range, 16.94 to 163 degrees Fahrenheit, really hot, right? I'm going to turn the one I just ran off, turn on this other one, and then turn off the digital number one, put it down below. So this other one, let's minimize this. I've categorized into, really hot, quite hot, warm, and cooler, right? And so gives you a sense where these different temperature ranges lie. If you wanted to, you can also display it as kind of a stretched image with these similar sorts of temperature contrasts like this. I'll turn this on. And then you can see kind of more variation in detail of these temperatures. Now these are degrees Fahrenheit, so we have quite a range here from like super cold, probably tops of clouds, to really hot, like black rock sitting on the desert, baking in the sun. These are surface temperatures, not air temperatures. Remember that. Surfaces get quite hot in the direct sunlight, especially if they're bare rock. But if they're covered in soil and things, they'll be much cooler. Okay, so that was run. You would do the same thing for 2023. And so here's that one, if you want to see it. categorized. And the reason why I categorize them is so that you can see in 2022, they're in the same categories, right? So the low temperatures go to 50, the high is about 130. So look at 2022, how many reds there are. And look at 2023, not much reds. Now, it's also a cloudier day. Look at all those purples. Those are the cloud tops. The scene could have been taken from a different time of day or a different week during June. So there might be actually difference in solar insolation because of that. And the temperatures would be different because of that. But it also could be directly tied to soil moisture and the difference in heat capacity when you have a wet soil versus a dry soil and more kind of grasses and things growing on a wet year. Okay, so that is here, and you can paste, your false color images in that look like this. You probably maybe want to show your scale bar too, and tell me whether it's Fahrenheit or not. Okay, so normalized difference vegetation index is the next thing. So let's minimize these surface temperature things. And we'll pull back up our surface reflectance data. And I've already loaded in the correct bands to do this. So normalized difference vegetation index, I've given you a little web tutorial on this. And I've also shown the formula here. But this is a normalized difference vegetation index. And there's other types of these indices of normalized difference to highlight vegetation or snow. They're useful in the following way. So for the example, we're using bands 4 and 5 in this particular case. And the reason for that is band 4 is red and band 5 is near infrared. So an active, happy photosynthesizing plant is going to be really green, right? But not red. So band 4 is going to be low values. Band 5 is actually going to be even more strong than green. We don't see near infrared, but plants, when they're photosynthesizing, give out a lot of that in terms of their reflectivity. And so, so band 5 will be high, band 4 will be low. So the numerator will be a big value if it's photosynthesizing, and we'll be dividing by band 5 plus 4. And so that's an addition. So the total value of this, if band 4 on the top was 0, then it would be band 5 over band 5, that would be 1. But it's always going to be a little less than that. So it's going to be a ratio that goes from this normalized difference vegetation index will be a ratio that will result in a number between 1 and -1. If it's not healthy vegetation, band 4 will be high and band 5 will be low, so it'll become a negative number. But again, you could never exceed 1 on the positive side or -1 on the negative side. So positive values are closer to 1, and that's healthy vegetation. We're in a desert, though, and so it tends to be that a lot of our value is going to be low or even negative because it's rock and not vegetation. And so I would say that anything that's positive and say greater than 0.15 or 0.2 probably has some healthy vegetation in it. And so I've given some suggestions down here about that. Okay, so let's turn on these bands. So if we turn on band 4 and 5 for these two, so here's 2023, and we're seeing red, the color red, but it's just stretched like black and white. So it's not true red, right? And then we could look at near infrared. Right? So those should be kind of anti-correlated, and they are. Look how bright the near infrared is in these ag regions, and in red they're not bright. They're low values, which will be in this case dark. but that's just how we've stretched it. Okay, so let's do the NDVI. So what we do to do the NDVI is we go back to raster calculator. Oops. Okay, so it cleared that. That might have been helpful. Let's open this up again so we can see what we're doing. And yeah, so we want to make sure we're using band 4 and band 5. And so what we do is make a parenthesis for the numerator. And we see that it is 5 minus 4 on that top. So band 5 for 2023. I had to double click it twice for some reason. Minus, and use this operator up here, 4. Parentheses. Okay, and then divide it by parentheses, the denominator, which is 5 plus 4 parentheses. And we're going to call this simply NDVI 23. Yeah, let's go ahead and run that. So this should work, and it did. Okay. So here's our output, and you can see the values range from a positive 0.8, and it's shown as closer to white here, to negative 0.25 as black. And so actually some of the blackest things are showing up with the clouds. Yeah, the clouds are definitely not vegetation. Okay, so cool. Where it's white is high, and those would be regions of vegetation. We can change this symbology if we want to. And you could do kind of a brown to green. But actually, I've got it oppositely oriented, so let's invert that. So the areas that are really highly photosynthesizing now are green, and yellow is kind of maybe a little bit of veg in these channels. And you can do this a number of ways. You could use any symbology class you wanted. If you want just 2 colors like this, it might be good. And then we could go to standard deviation. And then, yeah, it's looking pretty nice in terms of where we probably have vegetation at the high altitudes and these nice river valleys, and where we don't out in the Colorado Plateau, except for near the Green River or some of these little channels, tributaries that are more perennial. So this is 2023. Okay, so so you would do that for 2022 as well. And I've already done it. So I'm going to turn this one off and show you the ones I've already done because I've classified them slightly. Okay, so I'll turn on the one I just showed you, 2023. Okay, so I've classified it in this way. So basically, I made it clear, or maybe it's white. I'm not sure. Let's look at that. So if I go to symbology, I've done manual interval classifications. Yeah, I've made anything that I would say is not actively photosynthesizing vegetation as clear. And so I made a class of less than 0, 0 to 0.1, and I made those clear. And above 0.2, I made this light green, above 0.3, a slightly darker green, and then anything above that, sorry, 0.2 to 0.3, a slightly darker green, above 0.3, really green. And so that would be like really healthy vegetation, especially in this desert environment. And so you can see these agricultural fields and areas near towns showing up, high altitudes showing up in that dark green. But you get a good picture of it. And so the reason I classified it, manual classification, is so that I could directly compare these values to 2022. If you just do a stretch, they're normalized by the values that are that year. And you can see the range of values don't go as high. So in 2023, which was wetter, the peak value goes to 0.82. In 2022 doesn't get as high. And so that tells us something already, right? It's not as much healthy vegetation probably in 2022. But let's turn that on and we'll go back and forth for comparison. So this is 2023. Now watch me turn it off. Let's see 2022 show up in just a second here. So now I'll turn 2022 on. Okay, so it also has green. It doesn't have the clouds, but now turn 2023. And you see it gets a little bit more green, right? Especially in the desert region. But even in the non-desert regions, you can see the darker green popping down to lower elevations. And near the towns, a lot more green. And along the major rivers out here, quite a bit more green. Okay, so great. You can kind of visualize that difference in healthy vegetation. You can make a figure out of that, comparing things side by side. You don't have to do it for the whole area. If you want to focus on the San Rafael swell and one of the streams coming through, you could do that. But it says compare the area of land with vegetation in 2022 to that of 2023. How would you do that? That's a good question. So what you could do might be this. So you could go back to our geoprocessing. So go back to analysis tools. Analyze this a little bit. And we kind of did a thing before where we did reclassify. I think we could do that again. So we could input one of these classified NDVIs. So let's do that for 2023. And we could then say this first one is no data again, not healthy vegetation. No data again. Okay, and then if you want to call all of this healthy vegetation, you could, in which case you might want them all to be the same number, like 1. Or you could say, okay, the healthiest is 1, slightly less healthy is 2, slightly less healthy than that is 3. Okay, so then run that. So we basically reproduce this with some classifications. And then, yeah, and so 0, I don't know why that's showing up because we probably just make that blank. So those colors should kind of mimic the greens, right? Now that you might be like, well, that didn't really tell me much different. But if you go then to conversion tools, you can go from that raster to a polygon. And so you can input that reclass and NDVI raster and make a polygon and make multi-part features. So then we'll have just 3 classifications, and the value will be based upon value. So the feature will be based on value. So we'll have 1s, 2s, and 3s. I think this will be just one shape for each of them with multi-part. So let's run that and see what we get. Because the cool thing about this is then we can look at the attribute table and can see the area of each of the different NDVI values. Okay, so let's turn this off. And then we can go to this one and we can go to symbology and we can prove it to ourselves that we can do unique values based upon grid code. And yeah, so 0 can call that no color. So I don't think it exists. And then Go back. And then we gotta change these to slightly different colors. So 1 would be super green. 2 would be a little less green. And 3, the way I did it, would be kind of moderately dirty green or something. Okay, cool. So it did work. You can see a lot of other colors because I got these outlines of the polygons in there, right? So you basically classified the landscape in terms of different vegetation values. You can even click on them, but I've got a bunch of things open, so it's getting a little confusing. Okay, so trying to draw all those, it does take some time. But here's going to be the value of this, because I asked you to compare the area of land. So if we go to the attribute table, you can see that 616 square meters is that really healthy vegetation. Much more is that second class, and much more is that third class. And there are a lot of kind of, apologies, sorry, 0. For whatever reason, there was a 0 in there. So 1 was actually quite a bit of land. That makes more sense. But 2 and 3 are even higher. So careful of ID versus grid code. So 1, 2, 3. But there's our areas in square meters of each of the healthy vegetation. So you could directly compare that from what we did here for 2023 to 2022. And so you could quantify for me the extra area that's healthy vegetation between those 2 years. Okay, so yeah, I hope that helps you get started and basically make your way through this lab. I know it's a lot. I'm here to help you guys. Call me over as you're working. I can help you solve little issues that you might be having or questions. All right, so thank you.